I was reading this book right here. In my language, it was called Entendendo Algoritmos. In English, the title is something like uh, Grokking algorithms. And the first algorithm that we learn is binary search. That's a algorithm that starts in the first index and go to the middle, sees if it is higher or lower than the target is higher or lower than the number in the middle. If it's higher, we get the another portion and go to the middle. It's higher or lower, and doing that we can is lower. We go to the middle, and we are doing that until we find the right target. So or doesn't find. It's we have this option, but right now I have this visual function to test everything, and I will show you to you guys. Uh, or run it. I have this. I asked Gemini to generate these examples for me. Okay, with negative numbers and repeated numbers, and I change a little the perspective of the book. So this is just the binary search. I divided this in first, find first and find last, just to do with some example here. But right now we have the target, the how many numbers we encountered, and the position of the numbers. If there is only one, we only print one position, and if the target doesn't exist, 88 doesn't really exist in this array, we just send this text. Target doesn't exist inside the array. Okay, if we have more numbers, we have this. The target is 250, and we encountered this number 4 times. The first position was in position 1, and the last position was in position index 4. So that's it. Okay, you can see right here that works. And how I do the algorithm here, we start here in the lower position and the highest position in the index. Okay, and we have this result. This result is something that stays on -1 until we prove that we found the target. Okay, so if this doesn't found the target, the first or the last one is the same in both functions, returns -1. And if we return -1, the program understands that we don't find the right target. In this function, in both functions, we receive an array of ints and the target number. Okay. In this while here, we are going to divide the portions of the array. So we need to the higher and the lower meets, or the higher need to be lower than the lowest point, the lowest pointer. So this pointer needs to be lower or equal to this pointer here. Okay, because in the time that we are going like shrinking the array, there is some point that we are equal, and this finishes the array. Or if passes, the higher pointer passes, we already ended the options that we have. Okay, this is something we use to not get index out of bounds. So there is some mathematical explanation for this, but we get the higher number, subtract the lower number to get a number that we will add the lower number here and divide it by 2. Okay, that's the one to avoid index out of bounds. In Python, I think that's the Python works without this thing, but works like this in Python. I think I see this in Augusto Galego course, algorithms and data structures. But right now we are doing Java, and this is a problem, so we add this mathematical expression here. Okay, getting back. I created a variable to store the array value. So this will get us the array in the position in the middle that we calculate here. Okay, and we get the value here in the guess to compare. It gets more visual when I see the variable and what it represents. So I compare the variable with the target that we receive in the function, and if we found, we set the result to the variable, to the index of the guess. So the result receives the index, and here we are getting the higher pointer. So we started here and here. This is our portion of the variable. So we get this pointer here, and we get to the middle because it's lesser. So we already found the number here in this part. We already found it. So like in this example, we go here, after we go here, something like this or this, and after that we go here or something here. We found it, but not the first one in the array. So we get this another portion, and we get this portion, but it's not the first. So we divide it again and get this portion until we find this one. This is defined first. Okay. When we are doing that, if we can't find in the first, like here, in the first portion, we stay here. It's not our number. So here we going to this one. If our target is higher, if your target was, if your guess was higher than the target, we set the pointer, the higher pointer to the middle. If your guess was lower, we set the lower to the right. Okay, the find last is the same, but we are doing to the right. So we are trying to find the last one. In this example, we are doing the same thing. We're going here. So after that, we are separating things like this. And after that, we found our number right here. But it's not the last one. So we go +1, +1. Okay, because we already find it. So the difference is how we move the pointer here, the lower pointer of the thing. Okay, explain it. That's it.